What are aerosols? Aerosols are tiny particles suspending in the air. Some occur naturally, originating from volcanoes, dust storms, forest and grassland fires, living vegetation and sea spray. Human activities, such as the burning of fossil fuels and the alteration of natural surface cover, also generates aerosols. Average over the globe, aerosols made by human activities currently account for 10% of the total amount of aerosols in our atmosphere. Most of that 10% is concentrated in the northern hemisphere. Can you think of a reason why? We have much to learn about the way aerosols affect global and regional climate. We don't know in what regions of the planet the amount of atmospheric aerosol is increasing, decreasing, or remaining constant. Overall, we don't know whether aerosols are warming or cooling the planet. So why do we care about aerosols? Aerosols tend to cause cooling of the Earth's surface immediately below them. Because they reflect sunlight back into space, aerosols have a direct cooling effect by reducing the amount of solar radiation that reaches the surface. It is thought that aerosol cooling may partially offset expected global warming that is attributed to increases in the amount of carbon dioxide and other gases from human activity. Did you realize if there were no aerosols in the atmosphere, there would be no clouds? What can you say about the relationship between clouds and aerosols? Aerosols are believed to have an indirect effect on climate by changing the properties of clouds. As aerosol concentration increases within a cloud, the water in the cloud gets spread over many more particles, each of which is correspondingly smaller. In this way, changing aerosol in the atmosphere can change the frequency of cloud occurrence, cloud thickness, and rainfall amounts. Also, clouds with low aerosol concentration and a few large droplets do not scatter light well and allow much of the sunlight to pass through and reach the surface. However, the high aerosol concentration in these clouds allows for the formation of many small liquid water droplets. Up to 90% of visible radiation or light is reflected back to space by such clouds without reaching Earth's surface. Probably the best known evidence of the effect of aerosol in the atmosphere occurred in 1991. A severe volcanic eruption from Mount Pinatubo, Philippines, put an estimated 20 million tons of sulfur dioxide into the atmosphere. Aerosol from that eruption stayed in the atmosphere so long that average global temperature over the following year cooled by about 0.5 degree. Scientists have been observing clouds and aerosols globally from space for many years using sensors that measure the amount of energy leaving Earth. The sensors observe how clouds and aerosols vary with latitude and longitude, but provide little information of what is inside the clouds or on how they vary with altitude. So the next time you wake up on a hazy summer day, you can tell your friends that the haziness may be caused by sandstorm or volcanic eruption that occur halfway around the world.